Alright, welcome back. So, last time we finished selecting and setting up our swap chain, and now we are on to image views. And so just to check everything still works fine, let's build our game. Cool, alright, yeah, things are working good. Okay, so let's just jump straight on into it. Okay, to use any VK image, including those in the swap chain, in the render pipeline we have to create a VkImageView object. An image view is quite literally a view into an image. It describes how to access the image and in which part of the image to access. For example, if it should be treated as a 2D texture depth texture without any mip mapping levels. Mip mapping, I think, is... I vaguely remember hearing it was something to do with if you're translating texels to voxel, texels to pixels. I don't know. We'll get to that another time probably. In this chapter, we'll write a function that creates a basic function called this. Sorry, that creates a basic view image for every image in our swap chain, so that we can use them as color targets later on. So first add a class member to store the image views. Alright, so that'll be on our, right here, on our abstract. So it's an array of VkImageView, and it's going to be pointer to swap chain image views. Excellent. Then we create this function and call it right after the swap chain creation. So down here, let's put the void so-and-so. It's definitely going to take an app pointer. And then, create swap chain. Below this function, we'll do void again, create takes our app and a pointer to papp. And we want to call it right after create swap chain is called, which is here. Alright, excellent. We are getting closer. Alright, first thing that we do is resize the list to fit all the images and the views that we're creating. Okay, so we've already got the count of all the images in one of these things in the struct. Here you go, image count. Whoops. I believe, yeah. So we passed that to, well, we checked if it was below the minimum image count of the swap chain capabilities or above the maximum, and then rejigged it from there. And then we passed it into this one here, this function here, this vk swap chain images, which potentially updates it. So, and then we pass it back in again, along with our actual swap chain images, which get updated. Cool. So we need to update our newly created swap chain image views to be the same size. Create image views. So this papp needs to be of the same size as papp. Did we save that image count anywhere? I don't know if we did. We did not. No. Okay, I guess that's something we got to do, because we can't. I mean, we could create a function to count how many elements are in an array, but rather than doing that, let's just add the number of images. So we've got swap chain images, swap chain image count, u32. So when we do this image count update, let's also update our swap chain image count to be this image count. except let's do it down below here. Okay, so now we can access it from there, but that's not how we access it. We need to first create, well, firstly do that correctly. Secondly, we need to create a temporary array to then store into our image views. So this is what type is it? VkImageView, couldn't I ask to create info? Oh, it's just a VkImageView. Okay, VkImageView. So this thingy is going to be what we are storing. Oops. God damn it. Alright, so this array is now going to be this. Cool. So that's us basically doing this resize. Yeah, and then now set up a loop to iterate over all of the swap-chain images. Can do. For u32, I equals 0, as long as I is less than our image count, and I++. Within this loop, okay, the parameters of the image view creation are specified in a VkImage create info, another create info. First few parameters are straightforward. We have the S type, which is the struct type, I guess, and the actual image that we're iterating over. All right, the view type and the format fields specify how the image data should be interpreted. The view type parameter allows you to treat images as 1D textures, 2D textures, 3D textures, and cube maps. Right. Oh, cube mapping would be what map's used for, I think. To readjust the image based on where it lands on a pixel grid. Create info, view type. Yep, that's what I get fine. The components. Let's just copy these for now. That's the wrong key. So is that. They're all the wrong key. Alright, equals the start of our struct. Alright. Except it's not called that, it's called... What is it called? It's our PApp swap chain images, I think. It's PApp. Yeah, alright, that's the correct one. And then we have view type, which I should copy and paste, but I'm already over here. VkImage view type 2D. 2D. All right. No error, so obviously exists. Format is swap chain image format, which is also on our PApp, I reckon. Swap chain image format. Yeah. The components field allows you to swizzle the color channels around. Okay, it says RGBA alpha. For example, you can map all of the channels to red for a monochrome texture. You can also map constant values of 0 to 1 to a channel. Okay, let's just use this. Default mapping. Grand. And then the sub resource range field describes what the image's purpose is and which part of the image should be accessed. Our images will be used as color targets without any mip mapping levels or multiple layers. That's why the base map mip level 0. We have a level count of 1. I'm not sure what base array layer is, but the layer count is also 1. Alright, if you're working on a stereographic 3D application, then you would create a swap chain with multiple layers. Okay, you could then create multiple image views for each image representing the view of the left and right eyes of an accessing different. Oh, that's like VR. Cool. We're not doing that though. So could be cool, but we're not cool enough for that. All right. And that looks like that's all of the fields. That's a lot of fields. All right. So creating the image view is now a matter of calling VkImageView. VkImageView, passing in our p-app device, the create info struct we just created, a null pointer, and the address of the swap chain image views, which we created up here. Oh, I wonder if we should do this, or we should just maybe just use this for now. And then once this gets updated, then we would update our perhaps. Guess we don't pass the pointer because it already is a pointer. Oh, image views at position I. That makes sense. Oh, I've just done the wrong thing. You nut. Oh, no, that's fine. This is our image view. I keep miscasing that. So if that doesn't equal VK success, then we know we've got an error. I also need to put that in an if statement. Then we'll do error, I think we're up to 5. We are. Promise one day we will get to doing that. Printf, making that a bit more semantic. Failed. Oh, exit is not error. We've already done 5, so it's actually 6. So we failed to create image views, apparently. Okie dokie. Unlike images, the image views are explicitly created by us, so we need to add a similar loop to destroy them again at the end of the program. All right, but don't we need to allocate? Yeah, no, don't we? I'm going to. This thing here. Oh man. Hey, come on, obey me. Right, outside of our loop, let's do that. Cool, so we need to do this loop again in our cleanup. And it looks like we do it at the very start. All right, so we call VK destroy image view, and we pass in our p-app swap chain image views at position I, as well as our device initially, and a null pointer because we are not giving it any specific information about the cleanup. Cool. That's all of the code required for this to run. Let's see if it does indeed run. Oh, it does indeed not run. The object type, blah, blah, blah. Invalid VkImage object. The spec. Invalid VkImage object. What is our VkImages? These are the things in the swap chain images. Oh, so our image is invalid. Righto. That gets added to this. Let's check it out. Weird. Let's check if it has a valid address at least. So let's go We'll do it for each image that we run through. Image address is equal to the pointer, and we'll also new line that. VkImages I, so that should print out our address. Image address, oh, there's only one image. Oh, we only got to one and we bailed. Oh. Let's do another loop of all of the image addresses. All right. Nil, hello. That doesn't seem right. Nil, nil, nil. That explains why we have some problems. Oh. Excuse me. What does it say here? Okay, let's take a look at where we actually create these images. So we're assigning them to this. Wait, where are we? Oh, I'm looking at the wrong thing. Our app here. Here's where we're assigning these images. So let's take a little walk through those images here as well and compare with what we end up having in the next function call. Let's see, initial image address. Clear, please. So our initial image address is like this. So we've got all the oh, someone's at the door. 2 seconds. Apologies for that. Right. So initially, turns out we do have all of our addresses, but then something goes wrong and we end up with a nil. How many are there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And why is there only one nil this time? Is this another memory bloody thing? 1, 2, 3, 4, 5. Looks like perfectly valid addresses. A different address. 1, 2, 3, 4, 5, 6. Ew. Hang on. What's the image count at the end of this? Image count. That'll be a D. Yeah, because that's after we are assigning the image count to this. I'll get the count directly from this pointer. Sorry, a pointer, it's just a struct member. Let's try that again. So we've got 5, 1, 2, 3, 4. Yeah, so where are we getting 6 from? Isn't that what we're counting through in the following? Yeah, in the other loops we're counting through the swap chain image count. And we are there as well. And that's what we just printed out. 1, 2, 3, 4, 5. Image address is 1, 2, 3, 4, 5, 6. Is our loop wrong? No, we're definitely going through the correct thing. Let's do a count here as well. Give me, god damn it, the count please. Oh yeah, sorry, it's the wrong data type. Yes, but I do not want to quit Emacs. 5, 5. So why are we counting 1, 2, 3, 4, 5, 6 in these image addresses? Bizarre. That is very bizarre. Are we counting through something else? No, that is right. double check. Sorry about this. Brain, you'll get there eventually. All right, so we have 5 images, then we have 5 images, but then for some reason we're looking at it through 6 times. And because these nils are popping up in different places, I have a feeling there's something funky going on. So let's just double check out what we're doing. So when we're assigning early, not early, but before we actually use this swap chain down here. Oh no, we're actually applying directly to here. Perhaps we should do this and then move down here. So we update this new local variable inside the VK function, VkImageViews swap chain images, and then we then assign it to our app struct member. And the swap chain image count, why is that getting updated separately again too? All right, let's run that again and see what's happening. Right, so count still 5. We still got this null here, and that's a different position to the previous ones. And this address is different again to this one. Perhaps putting these on the stack, because it's just locally assigned in a function, is not ideal. And the segmentation fault is another little interesting thing. Because this is just a validation error. It then continues to try and run, I think. Yeah, okay, something's going wrong. So the segmentation faults make me think that potentially that cleanup function is being called. I'm going to check if it's being called once we hit this validation error. I don't think it is. I'm just going to put a print statement here. And it's going to be cleaning up brew. And I'll do the pointer address of this. Right. Nope, there's no cleaning up happening. What's the segmentation for all about then? Can that? Alright, instead of doing this, let's allocate let's allocate heap memory for this swap chain images. For these swap chain images, let's allocate some heap memory and see if that's the problem, because this is a local stack structure. This thing here, sorry, the swap chain images that we create here is a local to this function put on the stack. And I think when the function ends, it gets popped off the stack by the C runtime. So let's just give that a shot. So instead of doing the allocation down here, let's move up here, and we're saying, hey, this needs to be a, what is it, VK image pointer, and let's malloc it. Size of that multiplied by the image count. So that should allocate enough space for us to do this. And let me also, I'm curious about this as well. I'm just gonna log out the image count before this function call and again afterwards. Don't need you anymore, and we do need you because you're going to be allocating. You're going to be giving us the size So now we can once again pass this into the get swap chain images function, and then we will be looping through it once again. But let's just check this out. And down here, I think I probably just leave that function address there. Oh, I'll keep it there. I'll keep it there. Oh, just lock my screen. Oh, it's back. All right. Oh, the sixth item is because I am doing that again. What if I kill that? Anyway, let's try this. Build. Well, it didn't break. So the image count starts out as 4 and then it comes back out as 5 after that function call, and then it remains 5 when we need it. And all these addresses are now the same. Right, what if we clean up? Oops, I don't want to exit that. Whoa! Then we get lots of warnings, validation error. VkImage is not of type VkImage or image view. If image view is not a null handle, image view must be a valid image view handle. Okay, so here we're just assigning our images. It looks like malloc was an issue. I mean the lack of malloc, because it was the I've just figured it out. So before I was doing this where we had created our little local variable, and that is a pointer to the memory address of the first element in that list, which is currently 0. Like to null, but because we're not using calloc, which nulls the memory address, or whether it clears it, wipes it, I'm not really sure what the terminology is, but we're just saying, hey, give me this address on the stack. There might be something in there, might be nothing in there, there's probably going to be nothing, but it's a pointer to that memory address of the first element, or the first space in that array. So then we were assigning it like this, which means that this was pointing to a pointer of a stack-based memory, of some stack-based memory. So then when we're using it, it was getting correctly updated. But then when we leave the scope of this function, this stack memory was cleaned up. I think that's what's going on. It was cleaned up. So then this became basically just junk. Potentially it was the same, potentially not. Right. I think that's probably the reason. So we can nuke that. I think we can nuke all this too. Yes, we need to allocate memory. We then call this function, and then update the image count, which isn't the pointer, so that remains. That just copies it. It's like copies the value. Then we do this update, this update, this update. So we can probably kill this logging. Nothing else seems to be a problem there, I don't think. We're not doing an image view until later, yeah. So we're doing it again down here. Let me just ditch this. We have this locally scoped image array, sorry, of this correct size. We're then, going through and assigning a bunch of stuff to it, to that local stack-based memory. And then we're saying, oh yeah, just chuck that stack-based memory unknownly as the actual address. Like chuck those addresses into this array. Error. So again, we need to do something different, I think, and we say this now equals a heap-based memory array of this size. So we go size of our VkImageView struct, VkImageView struct, multiply by the number that we need, and I think that works for us. And then when we do update it, it's actually updating this, or the address of this. Right, how do you feel about that? Compiler. Feels good. What happens when we quit? Nothing. It all works fine. Excellent. All right. So that's a good thing to learn. If you create a local array, it's on the stack, but remember it's pointed to the address of the first element. So if you assign it to something which is going to be used outside of that scope, you're going to have a bad time. Great, we're done with this section. All right, an image view is sufficient. An image view is sufficient to start using an image as a texture, but it's not quite ready, of course it isn't, to be used as a render target just yet. That requires one more step of indirection known as frame buffer. But first, we'll have to set up the graphics pipeline. Cool, but we shall do that in the next one. So, thanks for watching me struggle and learn a little bit about stack and heap memory. See ya.